Thank you. This is basically a bimanual input method using both of their hands. With the one hand, we could highlight the key that we wanted to press, and then we made a pinch to select gesture in order to perform this action. So concerning the technology that we used the HTC Vive VR headset, on which we mounted the Ultralip Lips motion controller. This is basically a camera, and all it does is hand tracking. For the development, we use the Unity game engine and, of course, the API that Ultralip Motion provides. It includes an interaction engine, the way we could interact with the elements in the virtual space, and a simulation of our hands or 3D hand models. For that reason, we created 2 scenes in Unity, one for each method. And the research questions that we wanted to examine were what was the text entry speed for each of them, the error rates, and the user experience. For the keyboard, we were based on the QWERTY layout. It was a simple keyboard with the keyboard screen as an input field and the panel with the keys, the alphabet letters, the space button, and the backspace button. All these were interaction behaviors. This means that we could interact with them as if we were holding our virtual reality controllers, but instead of that, we used our bare hands. And we could, this could provide us various callbacks. For the first scene, the pseudo-haptic scene, we use only one hand to interact with this keyboard. Basically, what we have to do is hover the key and then make this natural press movement that we want whenever we want to press something in the space. And the feedback that we get is a color. The keys that are proximal to the fingertip are highlighted gray, and then when they're successfully pressed, they turn green. On our proposed method, the self-haptics method, we're using both of our hands, as I said. Basically, we use one finger to hover the key, to highlight the key that we want to press. And then by connecting our thumb and index, we make this action. The camera actually detected the pinch gesture and completed it. For our experiment, as I said, we wanted to investigate the text entry speed, the error rates, and the user experience. All of our participants went through the same 3 conditions. The first one was typing in a real mobile keyboard. We did that to examine the participants' skill baseline, and this included the WebTime online platform, which provided the users with random phrases. And it collected specific data that we used later in the process. And then they continued with the 2 VR applications that we made. They had to type 21 phrases, 3 blocks of 7 random phrases from the 200 memorable English phrase set. And we also made 2 questionnaires, a pre-questionnaire, which collected the demographic data of the participants, and we use the game experience questionnaire in order to compute the user experience. It examined the immersion, the flow, competence, the positive or negative effects, the tension, or the challenge that they may felt. Is everything okay? Do I continue? Okay. The data we collected from these platforms were from the WebTime platform, from the mobile keyboard, where the words per minute, the error rate, the keystrokes per character, the corrected error rate, and more. And from our VR sessions, we created 2 CSV files that wrote data during the experiment. And these data were, for example, the ID of the participant, specific timestamps, the phrase that they had to type, and the submitted phrase that they finally did, the character they pressed, and more. All this in order to compute the metrics that we were interested in. The procedure was simple. First, they completed the demographics questionnaire. They came to the lab where they became familiarized with the process. They completed a consent form, of course, and then they started with the baseline sessions, the mobile keyboard, and continued to the VR sessions with small breaks. After each VR session, they completed the user experience questionnaire. Here are the results. We had 24 participants age 19 to 32. Some of them had previous experience, and even one of them owned his own VR equipment. According to the English skills that they rated themselves, we see that most of them were advanced or proficient. The typing skills had an average of 3.5 as they rated themselves from a scale from 1 to 5. And the web time results that we collected were in line with the expected performances. So as I said, the metrics that we wanted to examine were the words per minute and the keystrokes per second for the text entry speed, and the total error rate and keystrokes per character for the error rates. Here are the results for the text entry speed. As we can see from multi-test, there is a significant difference between the two keyboard methods, concerning both the words per minute and the keystrokes per second. As we can see, the pseudo-haptics method made a faster text entry than the self-haptics. Self-haptics is a bimanual method, I'm just reminding. But we can see that the text entry speed is not very high, and that's due to the novelty of the experience. The lip motion tracking accuracy, we had a few problems with the detection of the hands and the target size because the keys were very small in the environment. But as we can see the performance over time, we can say that we have an improvement on the words per minute and the keystrokes per second. The low entry rates almost doubled by the end of the experiment, and we can definitely say that the participants became more proficient with training over time. Concerning the error metrics, we see that there is no statistically significant difference between the two keyboards for our metrics. The results are near identical, but for once again, by seeing the performance over time, we see decreasing numbers, and as the time got past, there were less errors. So once again, we can conclude that the participants became more proficient as they mastered their technique. Here you see the results we collected from our user experience questionnaire. We see a statistical difference in favor of the self-haptics method, our method, concerning the flow of the process. And here I have collected a few interesting comments that our participants made after each questionnaire. Concerning the self-haptics, the bimanual method, few of them reported to be fun, and they felt that they could afford good control over the input of the keys. They felt that they were typing faster once they mastered the technique. Some of them had a few problems with the hand tracking and the pins recognition, as I aforementioned, and 8 of them felt tired because they had to use both of their hands for the process. Some of them find difficulty synchronizing the two movements, the select and confirm actions of the process. And 4 of them suggested that a combination of the color highlighting and the pinch gesture would help them, the combination of the two methods. Concerning the pseudo-haptics, the color feedback, some of them reported that it was faster and effortless, it was more natural. A few of them were actually impressed by the experience. And what's interesting is that one person commented that he felt tricked into having an actual touch sensation when he pressed the key. Several of them reported that they felt tired due to the constant back and forth of the movement of the arm. And 10 of them on this method reported that they had tracking issues that produced many mistakes, and in that way they felt that they had less control on typing. We compared our results to similar researches that had been done in the past. For example, the pseudo-haptics and self-haptics for freehand mid-air text entry in virtual reality. They made a research, they also compared 2 methods, the self-haptic versus a pseudo-haptic. The difference is that it was on a large QWERTY keyboard, a desktop size. And another difference is that they were typing with both of their hands. So we can see by comparing our metrics that In their case, they do not have a significant difference between the words per minute, for the words per minute between their methods. But in our case, we do have a significant difference. Although there is a reasonable difference in the entry speed, we see in their case 19 words per minute, although ours are much less, and that's because our participants typed with only one hand on a smaller area. There is also a small difference in the corrected error rates, the error metrics, because in our case, the keyboard was small and we also had hand tracking issues due to the camera recognition. We also compared our results to the pinch text research results. This is a one-handed input method on a 12-key keyboard. They used their lower arm to select the keyboard row, and then they made a pinch gesture between the thumb and the index or the middle or the ring finger in order to select the columns. The difference is that they use the conductive tape to detect the pinch gesture, but in our case, we use the camera and our bare hands. So by seeing the performance on the 10 first and the next 10 phrases that the participants typed, we can say that in our study, we have bigger words per minute as a number. So we conclude that our bimanual method has a potential for higher text entry rates with, as we can see, comparable error rates. Last but not least, I would like to present the future work that we would like to make for this research. First of all, we should address the reported hand tracking issues in order to enhance the user experience and reduce the frustrations during the process. We could provide a more intuitive and comfortable single-handed interaction in order to reduce the need for coordination that we saw that made a few problems. We could make design adjustments and ergonomic considerations in order to optimize the hands movement, in order to minimize the physical strain. We could also provide additional feedback, visual feedback, such as the color highlighting or probably a cursor that would enhance the understanding and reduce the uncertainty during the process. Of course, training and mastery is important. We could provide training resources or tutorials in order to improve the proficiency and speed during the text entry. Of course, as I mentioned, the cursor could provide error reduction too. It could be an indicator, or we could add more gestures for the error correction to have more control over the input actions. And of course, we should conduct more studies with more experienced or familiar participants in order to collect additional feedback on the system's usability and the performance. All these on the context of enhancing the user satisfaction, increasing the input efficiency, reducing the fatigue, and of course, providing seamless and immersive text entry experience. Thank you very much.
Thank you. Questions? Oh, I see already. We'll take two questions in the interest of time. We'll take two questions now, and then you can catch up with Maria later and discuss the paper and ask her for more. So, Professor Avouris, please.
First of all, I'd like to congratulate you. Really amazing talk, exemplar research. Very well done to all the group of the authors of this. I really enjoyed it. Very well explained. Just a quick question. What was the motivation for not increasing the size of the keyboard? We have the fat finger issue relating to small devices like a smartphone. But here, because we are in a VR, and I've noticed another group used a full size and they had double the word per minute speed. I mean, why didn't you start yourself? Why did you confine yourself to small, which obviously reduces the rate of typing by your subjects?
Yes, of course. We don't want that. Well, the first idea, the initial idea, was to bring our mobiles into virtual reality environments. So in order to do that, we had to see how the interaction with the mobile, as we do in the physical world, would be in the virtual environment. And that's why we decided to keep this keyboard small, even though we knew that it would provide problems because of the hand tracking. This wasn't exactly as accurate as we wanted it to be. So yeah, that was the idea. We wanted to create this problem and see how it goes.
I think that also answers a question about the motivation of conducting research in text entry in VR. So using a traditional interface and moving it into VR,
Into
why do
something
we
else.
need
Yeah.
to do such a thing? But the idea of putting mobiles into a VR environment makes sense. Please.
Yes, my name is Mohammed Ubaid from Chalmers University of Technology in Sweden. Very nice work, nice research.
Thank
well
you.
done. Yes. My question, you mentioned a third condition, which is, I believe it's the baseline condition with the real keyboard. But I didn't really see much of the comparison or the results around that. So what was the
Okay.
reason around the baseline condition?
We created this condition in order to see if all of our participants would have the appropriate, the inline performances in order to move on to the VR keyboard. We did not compare the results of the VR keyboards to the actual ones. We just wanted to see if all the participants could have this baseline and go on to the next session.
Great, yes. And maybe later, I would love to see some videos of the setup.
Yes,
That'd be
okay,
great.
okay.
Thank you.
Thank you very much. Thank you, gladly. Thank you.